Determine whether the mean value theorem can be applied to f of x equals 2 sine x plus sine of 2x on the closed interval 0 to pi. And we want to find all value of c on the open interval 0 to pi that satisfies the mean value theorem. Okay. Well, can we use the mean value theorem here? And well, the condition is that the function has to be continuous within this closed interval. We know that sine and sine of 2x are both continuous everywhere. All right, so their sum should also be continuous. So yes, we can use the mean value theorem. Okay, now the second thing to note here is we only find the values in the open interval, right? Not including the endpoints, okay? Well, let's take a look, right? What does the mean value theorem say? If we want to find the value c, right? We want to find a value such that f prime of c is equal to f of b minus f of a over b minus a. Okay, and in this case, of course, we have our a value and our b value. What is this really saying, right? We want to find the rate of change, right? For this function, we want to find the rate of change of the function between these 2 points, which is going to be the right side. Okay? And then we want to find, okay, is there a point, okay, whose tangent line has the same slope as that guy? Okay, so that's essentially what we're doing here. So we're going to do this in steps, okay? No particular order, but I guess we can find the rate of change first, right? So let's do that. We'll take f of pi minus f of 0 over pi minus 0. Okay. Well, what's f of pi? Let's go ahead and plug this in, right? We get 2 sine of pi plus sine of 2 pi, right? Minus f of 0. We'll go ahead and plug in 0 in here. We get 2 sine of 0 plus the sine of, well, 2 times 0 is just 0, right? And all of this over, well, pi. Okay? And wait a minute, sine of pi is 0, sine of 2 pi is 0, sine of 0 is 0. So we just get 0 over pi, right, which is just 0. Okay? So what does that mean? It means that if you drew this graph and you connected the points where x is 0 and x is equal to pi, right, that line, that secant line, is going to have a slope of 0. Well, we know that any line that has a slope of 0 is just a horizontal line. Okay. All right, so that's this side here, right? What's the next thing we want to do? We want to find f prime, right? We want to find the derivative of this function. Let's go ahead and do that. F prime of x, right? The derivative of sine is just cosine. And then the derivative of sine of 2x, we ought to use a chain rule for this guy, right? So we're going to take the derivative of sine of 2x, which is cosine 2x, times the derivative of that, which is just 2, right? So 2 cosine of 2x. Okay. All right, now technically we'll call it f prime of c, right? So we'll call that 2 cosine of c plus 2 cosine of 2c. And what do we want to do with this? We want to set it equal to the rate of change that we just found. We're going to want to set that equal to 0, right? We want to find the values of c, okay, such that 2 cosine of c plus 2 cosine of 2c is equal to 0. All right, well, how are we going to solve something like this? Well, the problem is it's cosine of c, which is fine, but we have a cosine of 2c, right? So we're going to use a double angle formula to sort of break this guy down. Well, we know that there are 3 different versions of the double angle formula for cosine, but in this case, I'm going to use that 2 cosine squared c minus 1, okay, because of the other term here, right? I want them to match. So let me go ahead and distribute through the 2, so I get 4 cosine squared c minus 2 is equal to 0. In this case, I can factor out the 2 and just sort of eliminate it, and I'm going to rewrite this in order. So I get 2 cosine squared c, and then this term is next, plus cosine of c, and then minus 1 equals 0. Hey, now I have a quadratic type equation, so I can factor this, right? I'm going to get, let's see, I'm going to get 2 cosine of c, right, the cosine of c here. Looks like a plus 1 and minus 1 equals 0, right? So I get 2 cosine of c minus 1 equals 0. I get cosine of c is equal to a half. Here I get cosine of c is equal to negative 1. Well, where does cosine equal a half? I think that's going to be at pi over 3. And where does cosine equal -1? And that's going to be at pi, right? Remember, here you got to be really careful, right? For the mean value theorem, we only find the values that are in the interior, right? Not on the boundary. So unfortunately, now don't get me wrong, right? At pi, the tangent line is going to have a slope of 0, right? But we cannot use pi here, right? So the only place that it'll happen in the interior is at pi over 3.